Welcome to Summarize Science. We all know AI is getting incredibly powerful, but it comes with a huge hidden cost, massive energy consumption. But what if we could build AI that works more like the most efficient computer we know of, the human brain? This is the goal of spiking neural networks, a type of AI that mimics how our own neurons communicate with electrical pulses, or spikes. A new paper presents a major leap forward in making these brain-like AIs more efficient and realistic than ever before. Traditionally, many learning algorithms for these networks are time-driven, meaning they update themselves at every single tick of an internal clock. This happens whether or not anything important is actually going on. That's like watching a security camera record an empty room for hours. It's inefficient and wastes a lot of resources. The researchers in this paper took a powerful learning rule and transformed it into an event-driven system. This means the network only does the hard work of learning and updating its connections when an actual event occurs, specifically, when a neuron fires a spike. This is far more efficient, just like a motion-activated camera that only records when there's something to see. To see if their new, efficient model could still learn effectively, they put it to the test on a challenging task, recognizing handwritten digits from a special dataset designed to mimic how our eyes see. And the results were fantastic. Their event-driven model performed just as well as the original, less efficient time-driven version, proving you don't have to sacrifice performance for efficiency. These graphs show both models learning at a very similar rate, with their errors decreasing over time. But they didn't stop there. They made their AI even more brain-like. For example, in the brain, not every neuron is connected to every other neuron. Connections are sparse and specialized. They also programmed in communication delays, acknowledging that it takes time for signals to travel from one part of the network to another, just like in our own heads. They even allowed the AI to operate continuously, meaning it doesn't need to be reset between learning samples, making it more fluid and adaptable. This amazing figure shows the network's activity before and after training. On the left, before training, the output is messy and incorrect. But on the right, after learning, you can see the network's output signal correctly matches the target, showing it has learned the task. Perhaps the most impressive result is the scalability. Previous models often worked with a few thousand neurons, but this new method was successfully tested on networks with up to 2 million neurons. This event-driven AI scaled incredibly well, opening the door to simulating brain-like networks on a much larger and more complex scale. So, let's recap the important points. Researchers have developed a new, event-driven method for training brain-like AI that is both highly efficient and more biologically realistic. It works by only making updates when neurons fire, incorporates features like communication delays, and performs just as well as older methods. Most importantly, it scales to networks with millions of neurons, a huge step towards simulating brain-scale systems. This work paves the way for a new generation of sustainable AI that uses less energy. It could lead to smarter, more efficient technology in everything from robotics to medicine, all by learning a few tricks from the human brain. Thanks for watching Summarize Science.